June 8, 1944. Senelager Training Grounds, Nazi Germany. The ground trembled, not from artillery fire or Allied bombing, but from the movement of a single vehicle crawling across the proving grounds at 4 miles per hour. Panzeroberst Hans Joachim Schroeder stood watching as 188 tons of steel, armor, and weaponry struggled to negotiate a gentle slope that Panzer IVs crossed without effort. The Panzer VIII Maus, Maus in German, named with the dark humor that characterized late-war German military projects, was anything but. At 33 feet long, 12 feet wide, and 12 feet tall, it was the heaviest tank ever built. Its armor was impenetrable. Its weapons could destroy any Allied tank at ranges exceeding 2 miles. Its engineering was a masterwork of German precision manufacturing. And it was completely useless. The prototype before Schroeder represented 2 years of development, consumed resources equivalent to 100 Panther tanks, and embodied Hitler's obsession with weapons so powerful that quantity became irrelevant. The Führer had personally ordered the Maus program in 1942, overruling objections from every competent engineer and field commander in the Wehrmacht. He wanted a tank that could withstand any weapon the Allies possessed. He got a monument to hubris that couldn't cross bridges, couldn't navigate roads, and couldn't be transported by rail without disassembly. As Schroeder watched, the Maus approached a concrete obstacle designed to simulate an anti-tank barrier. The tank's Daimler-Benz MB 517 diesel engine, producing 1,200 horsepower, more power than 3 Tiger tanks combined, strained audibly. The transmission screamed. The tracks, each weighing 10 tons, churned through the soil. And the Maus, the most powerful tank in the world, failed to climb a 3-foot obstacle. What Hitler and his yes-men in the armaments ministry didn't understand, what every field commander knew instinctively, was that tanks had to move to fight. The Maus could destroy anything, but first it had to reach the battlefield. And that simple requirement, mobility, was the one thing the Maus couldn't achieve. This is the story of how Nazi Germany devoted enormous resources to building a weapon that exemplified everything wrong with late-war German military thinking. It's a story about engineering divorced from reality, about dictators overruling experts, and about the fatal attraction of technological supremacy over tactical effectiveness. And it begins with a directive from Hitler himself, issued when Germany was already losing the war it should have been fighting with the weapons it actually needed. The directive that doomed resources, March 21, 1942. The Berghof, Hitler's mountain retreat. Adolf Hitler, Supreme Commander of German Armed Forces, studying reports from the Eastern Front, reached a conclusion that would waste resources Germany couldn't afford to squander. German tanks weren't dominant enough. The context was specific. Soviet T-34 tanks had proven superior to German Panzer IIIs and IVs in armor, firepower, and mobility. German tank crews were being outfought by Soviet equipment that combined capabilities German designs couldn't match. The sensible response would have been to accelerate production of the new Panther and Tiger tanks already in development, both offering significant improvements over existing designs while remaining producible in meaningful quantities. Hitler's response was different. He wanted a tank so powerful that Soviet weapons couldn't damage it, so heavily armored that Allied anti-tank guns would be irrelevant, so overwhelming in firepower that a single vehicle could dominate entire battlefields. He wanted absolute invulnerability through absolute superiority. Ferdinand Porsche, the automotive engineer who designed the Volkswagen and was personally favored by Hitler, received the directive. Design the ultimate tank with no constraints on weight, size, or cost. The only requirements were armor thick enough to defeat any existing anti-tank weapon and weaponry capable of destroying any enemy vehicle at maximum range. Porsche, who'd already designed the troubled VK4501P Tiger prototype that lost the Tiger tank competition to Henschel, embraced the project. He assembled a team at his Stuttgart facilities and began work on what would become Type 205, later designated Panzer VIII Maus. The design specifications read like fantasy. Armor: 240 mm frontal armor, 200 mm side armor, 105 mm rear armor. Armament: 128 mm KWK-44 main gun plus 75 mm KWK-44 coaxial gun. Weight: 188 metric tons, or 414,000 pounds. Engine: 1,200 horsepower Daimler-Benz MB517 diesel. Crew: 6 men. Maximum speed: 13 km per hour or 8 miles per hour on roads, 4 km per hour or 2.5 miles per hour off-road. To understand how absurd these specifications were, compare them to the Panzer IV, Germany's most produced tank. Panzer IV weight, 25 tons. Panzer IV armor, 80 mm maximum. Panzer IV armament, 75 mm gun. Panzer IV speed, 42 km per hour or 26 miles per hour. Maus weighed 7.5 times more than a Panzer IV, moved at 1/3 the speed, and consumed resources equivalent to 7 Panzer IVs. But it could survive hits that would destroy a Panzer IV, and it could kill targets the Panzer IV couldn't engage. The question nobody asked Hitler was, would 7 Panzer IVs be more tactically valuable than 1 Maus? The answer was obvious to anyone who understood armored warfare. Hitler didn't care about the answer. He wanted the ultimate tank, and resource efficiency was irrelevant to that obsession. The engineering nightmare. Porsche's engineers faced challenges no tank designer had encountered. Building an 188-ton vehicle that could move, fight, and survive required solving problems that violated the basic principles of armored vehicle design. The armor was achievable but impractical. The Maus's frontal armor plate, 240 mm of hardened steel, weighed 11 tons, a single plate. The complete armor shell weighed 130 tons, leaving only 58 tons for everything else: engine, transmission, weapons, ammunition, fuel, crew, and all mechanical systems. The armor was invulnerable by 1942 standards. No Allied anti-tank gun could penetrate 240 mm of armor. Even the Soviet 122 mm guns couldn't defeat that thickness at any practical range. The Maus would be immune to frontal attack from any weapon the Allies possessed. But the weight created mobility problems that couldn't be solved. The ground pressure, the weight distributed across the track surface area, exceeded the bearing capacity of most European roads and bridges. A Maus crossing a standard road would crush the pavement. A Maus attempting to cross most bridges would collapse them. The solution was wider tracks to distribute weight. The Maus tracks were 1,100 mm wide, 43 inches, nearly 4 feet of steel track on each side. The tracks alone weighed 20 tons combined. They distributed the 188-ton mass to a ground pressure of 1.45 kilograms per square centimeter, actually lower than many lighter tanks. On paper, this worked. In practice, the tracks were too wide. At full width, the Maus was too wide to fit on German rail cars. The solution was removable outer track sections that would be installed only for combat operations. For rail transport, the tracks would be narrowed to 1,000 millimeters. This added complexity, required special equipment for track assembly, disassembly, and meant the Maus couldn't deploy rapidly from rail transport. The engine presented different problems. Generating 1,200 horsepower required a 12-cylinder diesel engine weighing 4.5 tons. The MB-117 was derived from aircraft engines and represented excellent engineering, but 1,200 horsepower couldn't adequately move 188 tons. The power-to-weight ratio was 6.4 horsepower per ton, compared to the T-34's 18 horsepower per ton or the M4 Sherman's 14 horsepower per ton. The poor power-to-weight ratio meant abysmal performance. The maximum speed of 13 kilometers per hour required ideal conditions, paved roads, flat terrain, and no obstacles. Off-road speed dropped to 4 kilometers per hour. A Maus couldn't keep pace with infantry, couldn't reposition during combat, and couldn't pursue retreating enemies. It was a mobile fortification, not a tank. The transmission was perhaps the greatest engineering challenge. Transmitting 1,200 horsepower to tracks capable of moving 188 tons required a transmission stronger than anything previously built for land vehicles. Porsche's solution was electric drive. The diesel engine powered generators that provided electricity to electric motors driving each track. The electric drive system was innovative but added weight, complexity, and points of failure. The generators weighed 3 tons. The electric motors weighed another 2 tons. The electrical systems required massive cables, control systems, and cooling. The entire drivetrain consumed 12 tons of the vehicle's weight budget. And it still didn't provide adequate performance. Even with electric drive eliminating mechanical transmission losses, the Maus couldn't achieve the speeds necessary for tactical mobility. It was slow, ponderous, and vulnerable to being outmaneuvered by lighter, faster vehicles. The suspension system, engineering excellence, tactical irrelevance. The Maus required a suspension system capable of supporting 188 tons while maintaining gun stability and crew survivability. Porsche's engineers developed a system that was mechanically brilliant and practically useless. The suspension consisted of 24 road wheels per side, 48 total, arranged in 2 overlapping rows. Each wheel was independently sprung using coil springs with hydraulic shock absorbers. The system could absorb terrain irregularities while maintaining relatively stable ride characteristics for the crew. The complexity was staggering. Each road wheel assembly weighed approximately 200 kilograms. The wheel bearings were specially manufactured to tolerances of 0.01 millimeters, a precision that required specialized machinery and skilled labor. Each suspension unit included 3 separate springs, 2 shock absorbers, and mounting hardware that had to support loads exceeding any previous tank design. The maintenance requirements were catastrophic. Replacing a single damaged road wheel required jacking the entire 188-ton vehicle, an operation requiring specialized equipment that didn't exist in field conditions. The overlapping wheel arrangement meant accessing inner wheels required removing outer wheels first. A damaged inner wheel could immobilize the vehicle until heavy recovery equipment arrived. Field trials revealed another problem. The suspension, while effective at cushioning the crew, couldn't prevent the vehicle's mass from destroying terrain. The Maus left ruts 30 centimeters deep in soft soil. Roads were crushed under the weight. Agricultural land crossed by the Maus became impassable for conventional vehicles. Chief Test Driver Oberfeldwebel Kurt Arnhold reported after trials in September 1944, quote, "The suspension performs admirably in absorbing shock. The crew experiences less jarring than in a Panther, but wherever the Maus travels, it destroys the ground. We crossed a dirt road during testing. The road was compacted earth, suitable for truck traffic. After the Maus passed, the road was a trench. No wheeled vehicle could use it. We don't just occupy terrain, we destroy it." Unquote. This terrain destruction had strategic implications. The Maus couldn't operate in areas where subsequent forces would need to travel. It couldn't cross farmland without rendering it impassable. It couldn't use roads without making them unusable for supply trucks. The vehicle was tactically self-isolating. Wherever it went, other vehicles couldn't follow. The weapons, overkill incarnate. The Maus's armament was extraordinary and unnecessary. The main gun, the 128mm KWK-44L/55, was the most powerful tank gun in the world. The coaxial 75mm KWK-44L/36.5 was itself more powerful than the main guns of most Allied tanks. The 128mm gun fired a 28-kilogram armor-piercing shell at 920 meters per second. At 2,000 meters, this shell could penetrate 200 millimeters of armor, enough to destroy any Allied tank from the front at ranges where Allied tanks couldn't effectively return fire. The penetration capability exceeded any tactical requirement. There was no Allied tank with 200 millimeters of frontal armor. Most had less than 100 millimeters. The Maus's main gun could destroy targets it would never encounter. The gun's recoil forces presented unique challenges. Firing the 128mm gun generated recoil energy that would have flipped a lighter vehicle. The Maus's 188-ton mass absorbed the recoil, but the force still stressed the turret ring bearings beyond anything previously designed. Each bearing was custom manufactured, weighed 150 kilograms, and required precision grinding to tolerances measured in hundredths of millimeters. The turret traverse mechanism used two electric motors powered by the vehicle's main generators. Full 360-degree traverse took 60 seconds, slow by contemporary standards, but acceptable for a vehicle designed for defensive positions. The elevation mechanism was hydraulic, powered by a dedicated pump. Elevation range was -7 degrees to +23 degrees, allowing engagement of targets from hull-down positions or elevated terrain. The 75mm coaxial gun provided anti-infantry and light vehicle capability. This weapon alone was as powerful as the main gun of a Panzer IV. Having it as a secondary weapon was an absurd excess, but typical of the Maus design philosophy. If good, more must be better. The ammunition storage was equally excessive. The Maus carried 68 rounds of 128mm ammunition and 200 rounds of 75mm ammunition. Each 128mm round weighed approximately 35 kilograms complete, projectile plus propellant. The ammunition load weighed over 4 tons and occupied substantial internal volume that could have been used for fuel or mechanical systems. The practical effect of this armament was simple. The Maus could destroy any target it could see at ranges where the target couldn't effectively fight back. In theoretical duels, the Maus was unbeatable. In actual warfare, where mobility, logistics, and combined arms operations determine outcomes, the armament advantages were irrelevant because the vehicle couldn't get to positions where its weapons mattered. The production disaster. Hitler ordered 150 Maus tanks in 1942. The order was insane. Germany's entire 1942 tank production was approximately 6,000 vehicles. Building 150 Maus would have consumed resources equivalent to 1,000 conventional tanks, about 17% of total production for vehicles that couldn't be deployed effectively. The production plan was revised multiple times as reality intruded on Hitler's fantasies. By 1943, the order was reduced to 10 vehicles. By 1944, it was reduced to 2 prototypes. Even building 2 consumed resources desperately needed elsewhere. The manufacturing challenges were unprecedented. The armor plates required steel mills capable of casting 11-ton slabs of hardened steel. Only 3 facilities in Germany had the capacity: Krupp in Essen, Dillinger-Hütte in Saarland, and Škoda in occupied Czechoslovakia. Each armor plate required 72 hours of heat treatment to achieve proper hardness without brittleness. Quality control rejected approximately 15% of plates for internal flaws detected by ultrasonic testing. The welding process required specialized techniques and experienced welders. Joining 240mm armor plates demanded preheating to 300 degrees Celsius, multi-pass welding using electrodes specifically formulated for thick armor, and post-weld stress relief. A single weld seam on the glacis plate required 18 hours of continuous work by 2 welders working in shifts. The Alket factory in Berlin, assigned final assembly, had to modify their production halls to accommodate the Maus. The overhead cranes couldn't lift 188 tons, so specialized lifting equipment was installed. The assembly floor was reinforced with additional concrete to support the weight. The modifications consumed 3 months and diverted resources from Sturmgeschütz III production, a vehicle actually useful in combat. The first prototype, V1, was completed in December 1943 at the Alket factory. The vehicle was assembled without turret. The turret wasn't ready because the weapon systems were still being developed. The hull alone weighed 140 tons. Moving it from the assembly building to the test track took special equipment and took 3 days. Assembly worker Friedrich Kellermann, who worked on the Maus hull, later recalled, quote, "We were building a monster. Everyone in the factory knew it. The thing was so heavy that moving it inside the building required planning like a military operation. We used hydraulic jacks to lift it centimeter by centimeter, moved it on rollers, and prayed nothing broke. When we finally got it outside, we realized it couldn't fit through the main gate. We had to partially dismantle the gate. For a tank. It was madness, but it was our job." Unquote. The second prototype, V2, was completed in March 1944, this time with complete turret and armament. The finished vehicle weighed 188 tons as designed. Getting it onto a rail car for transport to test facilities required building a special loading ramp capable of supporting the weight. The loading operation took 18 hours and required 2 heavy cranes working simultaneously. The rail transport itself was problematic. The Maus was too wide for standard rail clearances when fitted with combat tracks. Even with transport tracks, it exceeded clearances in tunnels and under bridges. The rail route from Berlin to Kummersdorf Proving Grounds required advance clearance, removing obstacles, verifying bridge capacity, and ensuring no rail traffic would be on adjacent tracks when the Maus passed. The test driver's perspective. Oberfeldwebel Kurt Armhold was assigned as chief test driver for the Maus prototypes in January 1944. His background was conventional armor. He'd driven Panzer IIIs and IVs in combat on the Eastern Front before being recalled to Germany for test duties. His first impression of the Maus was disbelief. Arnhold's test diary, recovered after the war, provides insight into the vehicle's characteristics from the driver's perspective. January 15, 1944. First time inside the Maus driver's compartment. The controls are familiar: steering levers, throttle, brake, but the scale is wrong. Everything is heavier, harder to move. The steering requires both hands on the lever to turn. The throttle is stiff. The instruments show engine temperature, oil pressure, generator output, standard equipment. But there's a tension gauge showing electrical load on the drive motors. I've never seen that in a tank before. January 20th, 1944. First drive. The engine starts easily, one advantage of the diesel. The initial movement is violent. The electric motors engage suddenly, the vehicle lurches forward. I'm used to gradual acceleration in mechanical drive tanks. This is different. The power is there instantly, but the mass resists movement. It's like pushing against a wall that suddenly gives way. Maximum speed on the test track, 11 kilometers per hour. Steering is exhausting. My arms are sore after 30 minutes of driving. February 3rd, 1944. Off-road trials in soft ground. The Maus cannot maintain direction. The tracks slip. The vehicle slides laterally on slopes. Steering in mud requires full strength on both levers. We got stuck in a depression. It took 2 hours and a heavy recovery vehicle to extract us. The engineers are concerned about cross-country mobility. I'm concerned about ever operating this vehicle in combat conditions. March 12, 1944. Obstacle trials. We attempted to climb a concrete barrier 1 meter high. The Maus approached at maximum speed, 9 kilometers per hour in this terrain. The nose hit the obstacle, the engine roared, the track spun, the vehicle stopped. We cannot climb obstacles that a Panzer IV crosses easily. The engineers are discussing modifications. I am discussing whether this vehicle is a tank or a bunker that happens to have tracks. April 8, 1944. Endurance trial. We drove the Maus for 4 hours continuous operation. Fuel consumption was catastrophic. We burned through 400 liters. That's 100 liters per hour, 100 kilometers per liter consumption rate. The operational radius is perhaps 50 kilometers before refueling is required. How would this be accomplished in combat? The vehicle cannot approach standard fuel trucks. It would collapse the ground beneath them. Fuel trucks cannot approach the vehicle on soft ground. The logistics are impossible. Arnhold's final diary entry, dated April 20, 1944, was prophetic. I have driven every variant of German tank from Panzer II to Tiger. The Maus is the most impressive and the most useless. It cannot fight because it cannot move. It cannot move because it is too heavy. It is too heavy because the armor is too thick. The armor is too thick because someone wanted invulnerability. We have achieved invulnerability by building a vehicle that cannot reach the enemy. This is not a weapon. This is a monument to confusion about what tanks are supposed to do. Testing the fording system. Near disaster. The Maus's inability to cross bridges required an alternative river crossing method. Porsche's solution was underwater fording. The tank would drive across river bottoms completely submerged, using a snorkel system for engine air intake. The engineering challenges were substantial. The entire vehicle had to be waterproofed to withstand pressure at depths up to 8 meters, or 26 feet. Every hull penetration, hatches, vision ports, and gun mantlets required special seals. The electrical systems had to be protected from water infiltration. The snorkel had to extend high enough to remain above water when the vehicle was on the river bottom. The snorkel system itself was impressive. A telescopic tube extended 8 meters, or 26 feet, above the turret, providing air intake for the engine and crew compartment. The tube was rigid enough to resist water flow, but lightweight enough not to destabilize the vehicle. Special valves prevented water from entering if the snorkel was submerged by waves or currents. The first fording trial was scheduled for May 15, 1944, at a controlled water channel at Kummersdorf. The channel was 20 meters wide, 6 meters deep, with concrete bottom, ideal conditions for testing. The Maus would enter the water, descend to the bottom, drive across, and emerge on the opposite bank. The trial began at 900 hours. The Maus approached the water entry ramp, the snorkel extended to full height. Arnhold was driving, with Porsche's engineers observing from the opposite bank. The vehicle entered the water slowly, maintaining 2 kilometers per hour to avoid creating waves that might swamp the snorkel. At 9:15 hours, the Maus was fully submerged. The water level was 5 meters above the hull, the snorkel extending 3 meters above the water surface. Arnhold reported via radio that all systems were functioning normally. The engine was running smoothly, the electric motors were driving the tracks, the vehicle was moving forward underwater. At 9:18 p.m., disaster struck. The hull seal around the driver's hatch failed. Water began flooding the driver's compartment at an estimated rate of 50 liters per minute. Arnhold reported flooding and attempted to reverse course. The electric drive system, exposed to water infiltration, began shorting. The motors sparked, smoke filled the crew compartment, and the vehicle stopped. The Maus was now immobilized on the bottom of a 6-meter-deep channel, with water flooding the crew compartment and electrical systems failing. Arnhold and the crew had approximately 10 minutes of breathable air before the compartment flooded completely. Emergency protocols were activated. A heavy crane positioned on the bank attempted to attach recovery cables to the Maus, but the vehicle was too deep. Divers entered the water to attach cables to towing points, but the water was murky and the towing points were difficult to locate. At 09:35 hours, 17 minutes after flooding began, divers successfully attached cables. The crane began lifting. The Maus, weighing 188 tons, plus water in the flooded compartments, was too heavy for the crane. The crane's cables stretched, the crane tipped forward, and operators had to release tension to prevent the crane from being pulled into the water. A second crane was brought to the site. At 09:55 hours, both cranes working together began lifting the Maus. The vehicle rose from the channel bottom slowly. At 10:15 hours, more than an hour after the flooding began, the Maus broke the water surface. Arnholt and the crew were extracted, all alive, but suffering from exposure to cold water and smoke inhalation. The post-trial analysis was devastating. The waterproofing seals, while theoretically adequate, failed under actual operational conditions. The electrical systems, despite being protected, were vulnerable to even minor water infiltration. The recovery operation demonstrated that extracting a flooded Maus from a water obstacle would require equipment that didn't exist in field conditions. The underwater fording capability was abandoned. The Maus would have to avoid water obstacles entirely, which eliminated most of its potential operational area in European terrain. The Hitler factor, obsession over reason. Understanding why the Maus program continued despite obvious impracticality requires understanding Hitler's personal involvement. The Führer wasn't merely approving a weapons program, he was personally invested in the concept of ultimate weapons that would restore German military superiority through technological dominance. Hitler's military judgment had become increasingly disconnected from reality by 1942. Early war successes convinced him that willpower and technological superiority could overcome numerical disadvantages. The Maus embodied this belief, one vehicle so superior that it would dominate battlefields regardless of enemy numbers. Albert Speer, Minister of Armaments and War Production, attempted multiple times to redirect resources from the Maus to conventional tank production. In a meeting dated June 8, 1943, Speer presented data showing that resources consumed by 2 Maus prototypes could build 100 additional Panzer IVs. Hitler's response, recorded in meeting minutes, "Numbers are irrelevant. One Maus will accomplish more than 100 conventional tanks because it cannot be destroyed and cannot fail to destroy its targets." The statement revealed Hitler's fundamental misunderstanding of armored warfare. Tanks operated as part of combined arms teams, supported by infantry, artillery, and logistics. A tank that couldn't maneuver with other forces was useless regardless of its individual capability. Guderian attempted to explain this to Hitler in a September 1943 meeting. The conversation, reconstructed from Guderian's post-war memoir and meeting notes, was illuminating. Guderian, "My Führer, the Maus cannot be employed tactically because it cannot move with other forces. It cannot cross bridges with other vehicles. It cannot be transported with our logistics systems." Then build stronger bridges, modify the logistics systems. The Maus represents the future of armored warfare. The future of armored warfare requires mobility, coordination, and combined arms operations. A vehicle that cannot participate in these operations has no future. You think too conventionally. The Maus makes conventional thinking irrelevant. When the enemy encounters vehicles they cannot destroy, their morale will collapse. The conversation ended without resolution. Hitler ordered the Maus program to continue. Guderian returned to his headquarters and wrote in his diary, "The Führer has lost touch with military reality. He believes in wonder weapons that will win through intimidation rather than capability. We are building tanks too heavy to fight while losing battles for lack of tanks that can fight." The alternative: what could have been built? The resources consumed by the Maus program, steel, machinery time, engineering expertise, could have produced weapons Germany desperately needed. A precise accounting reveals the opportunity cost. 2 Maus prototypes consumed 150 tons of steel, 18 months of specialized engineering, 75,000 man-hours of machining, test facility time equivalent to 200 tank trials, specialized tooling worth 2 million Reichsmarks. The equivalent resources could have produced 150 Panzer IV medium tanks, or 75 Panther medium tanks, or 50 Tiger I heavy tanks, or 300 Sturmgeschütz III assault guns. Each alternative would have provided combat vehicles deployable immediately, maintainable in field conditions, and tactically effective. Instead, Germany got 2 prototypes of a vehicle that never fought. The strategic impact of those alternative vehicles would have been significant. 150 additional Panzer IVs could have equipped 3 additional Panzer divisions. 75 Panthers could have reinforced the Eastern Front, where German armor was being attrited faster than it could be replaced. 50 Tigers could have provided heavy armor support for critical defensive battles in 1944. 300 assault guns could have supported infantry operations across multiple fronts. The Maus program's opportunity cost was measured not just in resources, but in lives. German soldiers fought with inadequate armor support because resources were diverted to superweapons. Defensive positions were overrun because the tanks that should have reinforced them were never built. The strategic consequence of the Maus wasn't just waste, it was contributing to defeat through resource misallocation. Post-war analysis by Allied intelligence estimated that the Maus program's resource consumption extended the war by approximately 2 to 3 weeks through its impact on German armored forces availability. This calculation assumed that the equivalent conventional armor, if deployed, would have stiffened German resistance enough to delay Allied advances marginally. The irony was perfect. Hitler's superweapon program helped Germany lose faster by denying resources to weapons that might have helped Germany lose slower. The comparative failure, Allied super-heavy projects. Germany wasn't alone in considering super-heavy tanks. The Allies experimented with similar concepts and reached different conclusions, illuminating why the Maus failed where Allied programs succeeded or were abandoned intelligently. The United States developed the T-28 T-95 super-heavy tank, a 95-ton vehicle designed to breach German fortifications. The design incorporated 305 mm frontal armor and a 105 mm gun. The T-28 was nearly as impractical as the Maus, slow, heavy, unable to cross standard bridges. But the American response to the T-28's limitations was different. When testing revealed the vehicle's impracticality, the program was canceled. Only 2 prototypes were built. Resources were redirected to more practical weapons. The cancellation decision was made by military planners, not overruled by political leadership. The British developed the Tortoise, an 80-ton assault tank with 225 mm frontal armor and a 94 mm gun. Like the Maus, the Tortoise was designed for breakthrough operations where armor protection mattered more than mobility. Testing revealed similar problems: too slow, too heavy, unable to operate effectively with other forces. The British response was identical to the American approach: canceled the program, salvage useful technology, redirect resources. 6 prototypes were built before cancellation. The program consumed resources, but not at the scale of continued production, despite obvious failure. The Soviet Union considered super-heavy tanks multiple times. The KV-4 and KV-5 programs explored designs up to 100 tons. Soviet engineers calculated that anything heavier than 60 tons couldn't be supported by Soviet logistics infrastructure. The programs were canceled at the design stage before consuming production resources. The pattern was consistent. The Allies recognized super-heavy-tank limitations and terminated programs before they consumed significant resources. Germany recognized the same limitations and continued anyway because Hitler personally insisted. The institutional difference was critical. Allied democracies had military procurement systems where field commanders, engineers, and planners could collectively cancel impractical programs. Nazi Germany had a system where Hitler's personal obsession overruled all technical and tactical objections. The result? Allied super-heavy-tank programs were terminated intelligently, while German programs continued to waste resources until the war's end. The T-28, Tortoise, and Soviet super-heavy projects proved that impractical tank designs were recognized universally, but only democracies could terminate them effectively. The final trials. By March 1945, Germany was collapsing. Soviet forces were approaching Berlin from the east. Western allies had crossed the Rhine. The war was lost, and the Maus program was still consuming resources. The two prototypes, V1 and V2, were at Kummersdorf, proving grounds, undergoing final trials when Soviet forces approached. The testing continued even as artillery fire could be heard in the distance, a testament to German bureaucratic momentum and the disconnection between frontline reality and rear-echelon programs. Test engineer Hauptmann Otto Karius was present at Kummersdorf in April 1945. His account, recorded in Allied interrogation after capture, described the final days. "We were testing ammunition loading drills on V2 while Soviet forces were within 20 kilometers. The absurdity was complete. We had a tank that couldn't fight because it couldn't move, testing systems that would never be used in combat, while the war was being lost around us. The officers supervising the tests acted as if nothing unusual was happening. They had orders to complete the testing program. Orders were orders, even when they made no sense." On April 14, 1945, orders finally came from Berlin: destroy the Maus prototypes to prevent capture. The demolition was assigned to engineers who'd worked on the vehicles, a final irony that the men who built the Maus would destroy it. Demolition charges were placed inside both hulls. The charges were positioned to destroy the engines, transmissions, and weapon systems without completely obliterating the vehicles, allowing post-war analysis of what the Germans had attempted. V1 was demolished on April 20, 1945, Hitler's birthday, though no one remarked on the coincidence. The charges detonated at 1400 hours. The explosion was violent, tearing open the hull and destroying the engine compartment. But the armor was so thick that the hull remained largely intact. The turretless V1 became a monument to incomplete development, a hull without weapons, destroyed before it could fight. V2 was demolished the following day. The charges were more carefully placed, intended to destroy the turret without completely destroying the hull. The explosion succeeded. The turret was damaged but remained structurally intact. The hull was shattered, the engine compartment destroyed, the electrical systems incinerated. Soviet forces captured Kummersdorf on April 21, 1945. The engineer units examining the site found the demolished Maus prototypes and initially couldn't identify what they were examining. The vehicles were so much larger than any known tank that Soviet engineers assumed they were fixed fortifications or experimental artillery pieces. When identification as tanks was confirmed, the Soviet reaction was amazement mixed with derision. Major Anatoly Burkov, commanding the engineer unit that examined the wrecks, reported, "We have captured the largest tank ever built. It cannot cross rivers, cannot cross bridges, cannot move faster than infantry marching speed. The Germans built this while losing the war. This explains why they lost." The Soviet salvage and analysis. The Soviets recognized the intelligence value of the Maus prototypes despite their impracticality. German engineering, even when misapplied, offered lessons on materials, manufacturing, and advanced systems. Soviet engineers spent 3 weeks at Kummersdorf examining the wrecked vehicles, measuring armor thickness, studying the electric drive system, and analyzing construction techniques. The assessment was compiled into a technical intelligence report dated May 15th. The report's key findings: armor technology. German armor quality exceeds Soviet standards. The 240mm plate shows uniform hardness throughout thickness, indicating advanced heat treatment. The welding technique used for joining thick armor is superior to Soviet methods. Recommendation: study German heat treatment and welding procedures for application to Soviet heavy tank programs. Electric drive system. The electric transmission is innovative but adds weight and complexity without corresponding benefits. The system is vulnerable to combat damage. Any hit penetrating the hull will likely damage electrical components. The mechanical efficiency is lower than conventional transmissions. Recommendation: do not adopt electric drive for Soviet tank designs. Weapons systems. The 128mm gun represents maximum practical tank armament. Larger calibers would require vehicles even heavier than Maus, which is already impractical. The gun itself is excellent, well-designed, accurate, and powerful. The fire control systems are advanced. Recommendation: consider 130mm gun for future Soviet heavy tanks, but not larger. Overall assessment. The Maus represents German engineering excellence applied to impractical design. The vehicle's technical sophistication cannot overcome fundamental tactical limitations. The Germans built the most powerful tank in the world and proved that power alone is insufficient. Soviet tank design philosophy, balance of armor, mobility, and firepower, is validated by German failure with unbalanced design. The Soviets decided to preserve one complete Maus for study. They salvaged V-1's hull and V-2's turret, combined them into a single vehicle, and shipped the composite Maus to the Kubenka Tank Museum near Moscow. The vehicle required special rail cars designed to handle the weight and consumed an entire train's cargo capacity for transport. The Maus arrived at Kubenka in July 1945 and became a centerpiece of the museum's collection of captured German vehicles. Soviet tank designers visited regularly to study the vehicle, learning what not to do in heavy tank design. The post-war verdict. After the war, Allied interrogation teams interviewed surviving Maus program personnel, engineers, test drivers, production workers, and military overseers. The consistent theme in these interrogations was recognition that the project had been doomed from inception. Ferdinand Porsche, detained by French forces in 1945, was questioned extensively about the Maus program. His defense was pragmatic. "I designed what was requested. The Führer wanted a tank with maximum armor and firepower without constraint on weight. I delivered that design. The tactical employment was not my responsibility." When asked if he believed the Maus could have been effective in combat, Porsche was candid. Effective? No. Impressive? Yes. The Maus was designed to specifications that made tactical effectiveness impossible. But refusing the Führer's requirements was also impossible. I built what I was ordered to build. Guderian, interviewed by American intelligence officers, was less diplomatic. The Maus represented everything wrong with late-war German weapons development. The Führer demanded wonder weapons that would win through superiority rather than strategy. We got weapons that impressed at demonstrations but couldn't be used in combat. The Maus was the worst example. A tank so powerful, it was useless. Test driver Arnhold, captured by Soviet forces and interrogated before being repatriated, provided the soldier's perspective. "I drove the Maus. It was an impressive machine, but I would never want to take it into combat. It couldn't move fast enough to evade artillery. It couldn't cross terrain that infantry could cross. It was a target, not a weapon. Any soldier would understand this, but the people ordering its development were not soldiers. The common thread through all interrogations was recognition that the Maus failed not because of engineering defects, but because the fundamental concept was flawed. Building the most powerful tank was pointless when that power came at the cost of mobility, deployability, and producibility. The museum piece. Today, the Kubenka Tank Museum Maus sits behind protective barriers in a climate-controlled building 60 kilometers outside Moscow. Visitors photograph it, marvel at its size, and wonder how Germany thought such a vehicle could be tactically useful. The statistics remain impressive. Length 10.2 meters, 33 feet. Width 3.71 meters, 12 feet. Height 3.63 meters, 12 feet. Weight 188 tons, 414,000 pounds. Armor 240 millimeters frontal. Armament 128 millimeters main gun, 75 millimeters coaxial gun. Crew 6. Speed 13 kilometers per hour maximum. The engineering remains excellent. The armor welds are perfect. The gun mechanism is precise. The electric drive system, though impractical, was innovative. Every component represents German manufacturing quality at its peak. But the vehicle never fought, never saw combat, never fulfilled its designed purpose. It exists solely as a museum exhibit, a captured trophy, and a reminder of what happens when engineering capability is divorced from tactical reality. The placard beside the Maus, written in Russian and English, explains its history. The final line reads, "Example of German engineering excellence applied to impractical design. Captured 1945, never used in combat. Heaviest tank ever built." That final line captures the Maus's legacy perfectly. Engineering excellence applied to impractical design. The Germans built the most powerful tank in the world, and it was useless. The Wunderwaffe delusion. The Maus was part of a broader pattern in late-war German military development, the Wunderwaffe, wonder weapons, obsession. Hitler believed that technological superiority could compensate for Germany's deteriorating strategic position. The Maus, V-2 rocket, Me-262 jet fighter, Type 21 U-boat, and numerous other advanced weapons programs consumed resources while failing to alter the war's outcome. The pattern was consistent across all Wunderwaffe programs. Technological innovation. Each weapon represented a genuine technological advancement. The engineering was sophisticated, the concepts were innovative, and the capabilities exceeded existing weapons. Tactical impracticality. Each weapon had limitations that reduced battlefield effectiveness. The innovations came with costs, complexity, unreliability, resource consumption, logistical requirements that outweighed the technological advantages. Resource diversion. Each program consumed resources needed for conventional weapons. The steel, machining time, engineering expertise, and production capacity devoted to wonder weapons were resources not available for tanks, aircraft, and equipment that could be deployed effectively. Strategic irrelevance. Each weapon, even when deployed successfully, couldn't alter the war's strategic trajectory. Germany was fighting enemies with superior industrial capacity, larger populations, and secure supply lines. Wonder weapons couldn't overcome these fundamental disadvantages. The Maus exemplified this pattern perfectly. It was technologically impressive, tactically impractical, resource-intensive, and strategically irrelevant. Building it consumed resources that could have extended the German resistance marginally. Instead, it consumed resources while contributing nothing to Germany's defense. Historian Richard Overy, analyzing German armaments policy, wrote, "The Wunderwaffe programs represented Hitler's fundamental misunderstanding of modern warfare. He believed wars were won by superior weapons. The Allies understood wars were won by adequate weapons produced in overwhelming quantity. The Germans built the best tank in the world once. The Americans built the fourth best tank in the world 50,000 times. Quantity proved superior to quality because quantity could be deployed and replaced while quality was captured in museums. The engineer's epitaph. In 1985, a group of former Porsche engineers who'd worked on the Maus program held a reunion in Stuttgart. By then, most were elderly, retired from post-war careers in the automotive industry. They gathered to remember their wartime work and reflect on what they'd built. Heinrich Kniepkamp, chief suspension engineer, spoke for many. "We built the Maus because we were engineers, and that was our job. We knew it was impractical. We knew it wouldn't change the war, but we were proud of solving the engineering challenges. Building a suspension system for 188 tons? That was interesting work. Building a vehicle that could fight? That wasn't our decision." The reunion produced a document, a collective statement from the surviving engineers about the Maus program. The statement, preserved in automotive engineering archives, concluded, "We designed and built the Panzerkampfwaffen 8 Maus. It was the heaviest tank ever constructed, the most heavily armored tank in history, and the most powerful tank of World War II. It was also useless. We knew this while building it. Engineers understand practicality, but engineers also follow orders. We built what we were told to build. The failure wasn't an engineering failure. It was a failure of leadership to understand that weapons must be usable, not merely impressive." The statement captured the tragedy of the Maus program: competent people executing incompetent orders, producing impressive results that were strategically worthless. The engineers did their jobs excellently. The job itself was the problem. The strategic autopsy. Post-war analysis by military historians consistently identifies the Maus as emblematic of Germany's strategic failures in weapons development. The problems were systemic: dictatorial interference. Hitler personally ordered the Maus despite opposition from field commanders and engineers. His authority overrode competent advice. The result was a weapon that satisfied political requirements while failing military requirements. Confusion of capability with effectiveness. The Maus was technologically impressive: the armor, the weapons, the electric drive. But technological impressiveness doesn't correlate with battlefield effectiveness. An inferior weapon that can be deployed is more valuable than a superior weapon that can't reach the battlefield. Resource allocation divorced from reality. By 1942, Germany was fighting a multi-front war against opponents with superior industrial capacity. The strategic requirement was to maximize combat power from limited resources. Building superweapons that consumed resources equivalent to 100 conventional weapons violated this requirement. Failure to terminate failed programs. The Maus should have been canceled in 1943 when trials revealed its limitations. Instead, the program continued for 2 more years, consuming resources even as Germany's situation became desperate. Institutional momentum and Hitler's personal interest kept the program alive long after it should have died. The Allies avoided these failures through different institutional structures. Democratic governments with civilian oversight prevented individual dictators from overruling technical expertise. Combined chiefs of staff systems forced inter-service cooperation and resource allocation based on strategic priorities. The culture of Allied militaries emphasized pragmatic effectiveness over technological perfectionism. The result: Allied weapons were often technologically inferior to German equivalents, but were more effective strategically because they existed in sufficient numbers and could be deployed where needed. The Sherman tank was inferior to the Tiger in direct combat, but for every Tiger built, the Allies built 20 Shermans. Quantity had a quality all its own. The final truth: On April 20, 1945, German engineers demolished the Maus prototypes at Kummersdorf, destroying the most powerful tank ever built. The vehicles had never fought, never seen combat, never fulfilled their designed purpose. They existed as testaments to the fatal attraction of absolute superiority over practical utility. The Maus could destroy any Allied tank at ranges exceeding 2,000 meters, but it couldn't reach positions where that capability mattered. It could survive hits from any Allied weapon, but it couldn't pursue enemies or support advancing forces. It was invulnerable and irrelevant simultaneously. In the museum at Kubinka, the composite Maus, V1's hull with V2's turret, sits as a monument to a specific kind of failure. Not an engineering failure. The engineering was excellent. Not manufacturing failure. The construction quality was superb. Strategic failure. The failure to build weapons that matched military needs rather than political fantasies. The Germans built the most powerful tank in the world, and it was too heavy to cross bridges, too slow to maneuver, too complex to produce, and too impractical to deploy. It never fought, never mattered, never justified its existence. It sits in a museum as proof that power without purpose is just expensive metal, that ambition without reality is just waste, and that the ultimate weapon is worthless when the war is lost for lack of adequate weapons produced in numbers that could fight. The thunder spoke, the ground trembled. The most powerful tank ever built couldn't move fast enough to matter, and Germany lost the war while building monuments to its own delusions.